Welcome you all. In this session, we are going to see the problems on DC machine using MATLAB code. So let us take this problem. A 250 kilowatt, 460 volt, 600 RPM, 6-pole DC machine is built with an armature diameter of 72 centimeter and core length of 27 centimeter. The lap armature winding has 660 conductors. Using this data, obtain a preliminary dimension for armature core, number of armature conductors and commutator segments for a 350 kilowatt, 500 volt, 725 rpm, 6-pole DC machine. Assume a square pole with pole arc is equal to 0.7 voltage. So in this problem they have given given the data for 250 kilowatt machine, and they have given even the armature diameter and core length. So from this the specific electric and magnetic loadings can be identified. Since the D and L value is known, here the unknown value loadings can be found. The same loadings is need to be used for the forthcoming machine, that is the newly designing machine, whose rating is going to be 350 kilowatt. Okay, this is how the problem is going to be for the. So usually in the problem they will be giving a hint for getting the value of specific electric and magnetic loading. Here instead of that, what they did is they have given given a machine rating and its data along with a D and L, and from this we are supposed to find the specific electric and magnetic loading, and the same loadings need to be used for the next machine which you are going to design newly. So this is the problem. So let's go. So usually for any problem we used to give the given data. So the given data we used to type here, we call them as the initializing the variables. So here the given problem P0 is 250 kilowatts, P is 600, therefore synchronous speed means capital N divided by 60. Then the notations which you use, it must be throughout the program you should use the same notation. You need not change anything. If you change anything, it causes error in the program. So the given data is given for the old machine. So similarly for new machine, conductors is Z and pole 6, input voltage is 460, and the output equation. So output equation PA is equal to C naught D square L Ns. It is noted, and here C naught is equal to PA into D square L Ns. So those values has been given. So the number of conductors per parallel path as lap winding, which is equal, since it is a lap winded machine, they have given in the problem clearly, they have stated it is a lap wounded machine. So what you can do, you can take the number of parallel paths is equal to number of poles, that is known quantity. So wherever we are mentioning a percentage symbol, that is nothing but, that is not a program syntax or something like that, that is nothing but for your understanding purpose you are mentioning it. So P path is equal to number of poles, number of parallel paths. Z path is equal to Z by number of parallel paths. So F printf statement is what else you need to print in the output screen, you can print with the help of F printf statement. So this is the syntax: F printf open bracket, then you have a call slash n. Next the things which you need to be typed in the output screen need to be typed, and you need to close it with a semicolon. So this is the syntax. So see, these things will be displayed in the output screen also. Okay, and if you want to get a value which is calculated, say for example, see the fifth line, number of conductors per parallel path, this will be displayed, which is equal to some numerical value needed. This numerical value will be already we have calculated, that is the Z path. So disk Z path. So disk means it takes the value that has been calculated by the compiler. Okay, so see is Z path. So this Z path is nothing but the value which need to be entered near to the equal. So again see, a printf statement is given for calculating Ez. I have given the formula, then display Ez. So this Ez value will be displayed here, hence the EMF induced per conductor. Now coming back to B average. So now B average need to be found, the specific loading. Once you know the value of specific loading, you can use it for the next machine, right? So this is V average is equal to Ez divided by L phi dns. So substituting, you'll be getting the value of B average. Now n1 and n1s. So initially we took a value n, that is the old machine speed. Now the new machine which we are going to design. So the speed is represented in terms of n1. It is not necessary you need to mention it as n1 alone. You can choose your own notation, n2 or n2 or n3, like that. You can choose your own value. So then P1, so again the armature for P1 given for the second problem. So they have taken second for the second machine, so they have taken as P1. It is also, again, it is not necessary you need to P1. So the notation which you are using, you need to use the same notation throughout the program. That is the thing. And d square L, same formula you need to use. And again here the hint given is square pole phase with polar by pole pitch is equal to 0.7. The psi value is given. So you are finding the value of D and displaying it. Again finding the value of L, and I am going to display it. Now let us see what will be displayed in the output screen. Before moving to that, two more things need to be taken. That is the Z path as well as Z lab. So number of conductors. So and the commutator. So the commutator diameter is 0.7 times of main dimension. We know that commutator pitch is pi d by p. So and now I am going to display these things. See the number of parallel paths, which is 110, hence the mean EMF of the conductor is 4.18, average flux density B average, then new D and L calculated, then the Z path and the number of conductors, then again the commutator segments, and commutator segments are within the limit. So these things has been checked. So the same problem as we manually calculate, we have done it in the MATLAB. Thank you.